Let's try and solve a hydraulic problem. And so let's start on the left once again with a taller, thinner cylinder. And let's connect that with a pipe connecting to, on the right, a short and wide cylinder. Now, you might notice that I'm drawing this cylinder a little bit more simply than before. Before we drew it more 3D like this, I can even show you up here. But this time we're going to draw it more of a side view where these cylinders just look like rectangles to us. And then the pipe connecting is just a simple line. And on the left side, let's draw a piston or a plunger, whatever you want to call it. And coming out of this piston, let's say we have some 50-pound weight. And on the right side, we'll have a piston with a weight. And let's say we don't know what this weight is. We'll just call it our force output, and we don't know it. It's just some big weight. And let's say that the piston on the left drops 5 inches as it goes down through our cylinder. And let's say we don't know how high our piston on the right will raise. We'll just call that our distance output. And so what do we know? Well, let's say that the area of the piston on the left is 4 inches squared, and that the area on the right is 20 inches squared. And so what do we need to solve for here? Well, first off, we need to solve for what our pressure is. Secondly, we need to solve for what our force output is. And lastly, we need to solve for what our distance output is, how far up this piston will travel. Okay, so the first thing we should solve for is the pressure, and that's pretty easy. We can just use that triangle that we created in the last video where we said that pressure and area are on bottom and force is on top. And so if we're looking for pressure, what do? Well, we look at the other two variables. Force is over area, so the formula for pressure is force divided by area. And we know the force and the area on the left. The force on the left is 50 pounds. And the area on the left is 4 inches squared. And so what is 50 divided by 4? Well, if we grab a calculator real quick, we can just say 50 divided by 4 is 12.5. And so we'd say our pressure is 12.5 psi, or pounds per square inches. Okay, so that was really easy. But then what about our force output? Well, if you think about it, we kind of already know everything we need to figure that out. And that's because, if you recall from our last video, we learned that pressure is constant throughout a hydraulic system. And so if the pressure over here is 12.5 psi, or every square inch there's 12.5 pounds of pressure, let me actually draw that out. We're going to draw 4 arrows, each one representing 12.5 pounds of force, totaling a total force of 50 pounds. Every square inch on the left has 12.5 pounds of force. And on the right, we do the same thing, but there's 20 square inches. So I will need to draw out 20 arrows for myself. And so if you want to know the force output, you just take 12.5 and multiply it by 20. And so let's actually draw that out for ourselves. We'll say we're using this to solve for our force output. And the force output is going to be equal to our pressure multiplied by our area. And how do I know that? Well, if we're looking for force, look at the other two variables. Pressure is next to area, so pressure times area. Just like before when we were looking for pressure, force is over area, so we did force divided by area. Okay, well, we actually know both those numbers. We just solved for pressure. We got 12.5 pounds for every square inch. So pounds per inches squared. And we're going to multiply that by our total area on the right, which is 20 inches squared. And so if we were to take 12.5 and multiply that by 20, what do we get? We get a total force output of 250 pounds. And if you couldn't tell, inches squared canceled out because we're dividing by it and multiplying by it in the same time, so we're left with pounds. All right, so that was pretty easy to solve for our pressure and our force output. And let's actually write this out for ourselves so that we have it. We can write below this, force output equals 250 pounds. And we can go ahead and box that for ourselves. And then off to the left, we can write pressure equals 12.5 psi. And we can go ahead and box that for ourselves. But what about our distance output? Well, to solve for that, we actually need to use an old faithful equation, and that is our mechanical advantage. And in this case, we know our two forces now. So we can say our AMA specifically, which is of course FR divided by FE. And we know our force resistance. We just solved for it. It's our output force of 250 pounds. And then our effort force would be our input force, which is 50 pounds. And so pounds cancels out, and we get 250 divided by 50 is just 5. And of course, if our AMA is 5, we can go ahead and assume an ideal effort force equation. Therefore, we can assume that our IMA is 5. And we can say our IMA is equal to, of course, the distance effort divided by the distance resistance. And that is 5. And that is equal to our distance effort, which is our input, which is 5 inches on top. And then what's on bottom is our distance output, is our distance resistance. And so hopefully this is pretty obvious. We don't have to do very much math. We can just say our distance output is just 1 inch. And if you think about it, that makes way too much sense. If the output force is 5 times bigger than the input force, then the input distance would be 5 times bigger than the output distance. Remember, work equals force times distance. But you might notice there's actually one more proportion that equals 5, and that is our two areas. 20 over 4 is also 5. And so let's go ahead and create ourselves a new mechanical advantage equation. We will call it our hydraulic mechanical advantage, or just HMA for short. Now, this equation will be unique to hydraulic systems and not our simple machines because they're not based on pressure and therefore not based on an area. But our HMA, if you look at it, would be equal to 20 over 4. Well, 20 is an area. It is our output area. So area out. And 4 inches squared is obviously on bottom to get us 5, and so that's our area input. Now, you might recall that when we were dealing with mechanical advantage, we deal with resistance and effort, not output and input, although they're kind of the same thing. But if you're super OCD like me, we can go ahead and rewrite this to say our area resistance divided by our area effort. And so how do you remember if it's resistance on top or effort on top? I'm not sure if there's anything funny we can come up with HMA like I'm a free and I'm a deer, but it's very simple. It's just the resistance over the effort or the output over the input, and we know those numbers is 20 inches squared on top, and we get 4 inches squared on bottom. Inches squared cancels out, and 20 divided by 4 is a mechanical advantage of still 5.